Alrighty, let's take a look at this question. So we have after 204 minutes, a sample of plutonium decreased to 1/64th of its original mass. The half-life to the nearest minute is. Okay, so the formula that I use is, and that's on your formula sheet for 30-1, is y equals ab to the t over p. Y being the final amount of something, A is your initial amount, B is your growth or decay rate, T is the amount of time for Y to happen, and P is the amount of time for B to happen. So when they use the word half-life, right away we know our B is equal to 1/2. So usually what I do is go kind of fill in the blanks. So blank there, brackets, and then something over something. But with half-life, I know in the brackets, the growth or decay rate will be 1/2. And then it said, what is the half-life? Meaning the amount of time for 1/2 to occur. So that's your P value on the bottom that we're looking for, because P is connected to B. All right, now let's see if we can fill in the rest. So it said after 204 minutes. Well, that would be the amount of time for the final amount to happen. So 204 would go in the numerator there. And it said decrease to 1/64th of its final mass. So they didn't, or initial mass, sorry, original mass. So they didn't tell us what that was, but if we said the original mass was like 1, then the final would be 1/64th, 1/64th of that. And that's probably the easiest way to do that. Alrighty, looks like we've got everything filled in. Now we just need to solve for P. You want to isolate your power, but really with that 1 in front, it kind of is isolated already. So we'll just rewrite that, making it look a little cleaner. All right, now I'm noticing here that we're not going to need to log both sides because our bases on these powers can be made the same. If I write 1/64 as 1/2 to some exponent, then our bases would be the same. So you just got to connect 64 and 2, because 1 to any exponent will still be 1. 2 to the 6 is equal to 64, so therefore 1/2 to the 6 will equal 1/64. Alrighty, now that we have that, our bases are the same, and we have a power equals a power, so therefore our exponents would equal each other. So 6 equals 204 over P. Now, the thing we're looking for is in the denominator, which is a bit of a pain, but essentially what you do is multiply both sides by P. That will get it out of the denominator. And then you would have 6P equals 204, and now we just divide both sides by 6. In essence, what happens is the 6 and the P switch positions. Okay, and then 204 divided by 6, let's get that number, divided by 6 equals 34. Now, units on that, since the number in the numerator of the exponent was in minutes, that would mean the p-value would also be in minutes. And they said to the nearest minute, so we're good. There we go. That should be the answer. Alrighty, hope that helped.